Hello, my name is printmaker Reinis Gailitis, and I wanted in this video talk about the fascinating connection between traditional art of printmaking and the modern technology. I have two things in my hands. One is a lithography stone used for printing for more than 200 years, and my other hand is a mobile phone. They might look like two completely different things, but actually they have a lot of in common, and similar processes that make printed from the stone are used in making semiconductors and microchips. We talk a lot about modern digital world, but the same principles that run our modern world are used back in the day for printing on paper. As a printmaker, I would like today lead you on this journey of lineage, how these traditional processes transferred into the making of the modern world. I hope this video is interesting not only for printmakers like myself, but also for people more educated in technology and engineering, for you to see where this all came from. I hope you enjoy the video. When we talk about the history of printmaking, oftentimes the conversation starts with Johannes Gutenberg, a German goldsmith and inventor. You've all heard about the Gutenberg printing press, which was invented in 1440. The printed book changed how we share the information. It became available for everybody. Printed books, encyclopedias, and so on. It allowed information to spread all over the world and change the societies in a way. But in broader terms, printmaking as an idea changed how we produce things. In its essence, printmaking is taking and making a single matrix. It used to be a wood block or copper plate, and then this piece would be used to manufacture and print multiples of the same image. These principles of multiplication were later used also in the manufacturing of semiconductors and computer chips. The interesting connection is that many of these people also worked previously in the printing industry, hence they were able to transfer this knowledge onto this other craft. In 1796, German actor and playwright Alois Senefelder invented the technique of lithography. Senefelder was looking for ways to more affordably print his plays and sheet music. By drawing with an oily crayon on a limestone, he realized that where he had made the oily, greasy drawing, the ink would stick, and where the stone was wet, the ink would repulse. Previously, if you wanted to make an image, you had to physically engrave or etch it in a metal plate or carve it in a piece of wood. What Senefelder did, he used chemistry instead of physical carving. Lithography is also called planography because unlike etching or engraving or woodcut, where you work on the relief of the block, in planography and lithography, the printing matrix is flat. There's no relief. All the printing is done from a flat surface based on chemistry and not on the height differences. And another technological breakthrough happened a couple decades later in France in 1820. French inventor Niépce was looking for a way to transfer photography onto the plate. In his experiments, he discovered that a certain type of asphaltum, bitumen, reacted with the sunlight. When exposed to the light, it would harden. What he did was making photography, laying it onto the bitumen, and in the places where the light would shine on it, it would harden, and in the places where it was kind of covered, it could be washed off, resulting to reveal a photography. It was the first light-sensitive photoresist that afterwards, in different ways and chemical formulations, would be used in different printmaking processes. He called it heliography, which literally translates to sun drawing, because as if sun was making the image for him. And later on, it was referred to as photo etching or photogravure. It was widely used in newspapers and books to reproduce photographic images. But how do we get from printmaking and photographic images on the metal plates to semiconductors? We have to jump another century in the future to London, where Austrian immigrant refugee Paul Eisler was also working in a printing workshop in London, printing, again, uh, note sheets. Back in the day, electronics didn't look the way they look now. There were jumble of wires and conductors, which are all made and soldered by hand. Because he worked in a printing workshop, all these techniques were familiar to him. So he thought, why can't I apply this knowledge that I already have to making a circuit? So what he did, he took a circuit board, laid a layer of copper onto it, exposed the circuit board layout onto the plate, and then etched it, revealing only the copper wires at the end. So the same logic of making a print was applied to making the first circuits. As technology advanced and became smaller and smaller, it was impossible to work on it with your kind of bare eyes. It was, just not reasonable anymore. So people were looking to a solution to this, how to make it even smaller. So we moved to the 1950s. J. Lathrop and James Knoll looked again to the printing industry. What they did was quite genius. They took a silicon wafer and coated it with the photoresist, as we described in the previous techniques. And afterwards, they turned to microscope. They turned to the microscope and flipped it around. Instead of looking at something small, they took a large circuit illustration and projected it on a microscopic level. Then, using the previously mentioned principles, they made a tiny microscopic circuit. In a nutshell, they didn't discover a new process. They took something existing and made it incredibly tiny. Today, this process is taken to an absolute extreme by the Dutch company ASML. They use extreme ultraviolet lithography to print semiconductors on almost anatomical level. There's a really great video by Veritasium that I really suggest you to check out. I'll add it in the bio. The process is so delicate that even air in the system would disturb the printing process. So all of it is happening in vacuum on anatomical level, basically creating small supernovae inside the machine that costs 400 million a piece, if I'm correct. So that would make it the most expensive printing run and press in the history. But it's not just lithography and photo processes and etching. There's another printmaking technique called screen printing that's also used in the manufacturing of modern technologies. In screen printing, with light, you expose a stencil onto a screen, and then you use a squeegee to pull through the screen a certain image onto the surface. Traditionally, screen printing is used for making posters, different things on paper, as well as printing on t-shirts, bags, and other places. But this process is not only used in screen printing as in printmaking medium. It's also used by engineers to print silver layouts onto the solar panels. It's used in different medical appliances, like printing chips for the diabetes patients to measure your sugar level. It is also used nowadays in the frontier of solid state batteries, where screen printing is used by layers to print lithium and carbon slurries. In screen printing, you're depositing a tiny layer of a material, so you're actually building up layers. So by these processes, you could produce solid state batteries and other things that will power our future potentially. Now we have to talk a little bit about uncomfortable topic at the end. that is development of AI. People, artists, me included, we worry about this technology a little bit. It has the potential to disrupt many things, art making, labor markets, and so on. And no doubt it will in some ways. But when we look at it, art and printmaking has been a stepping stone to that. AI, the modern semiconductors, chips, everything that powers our mobile phones, our screens, our solar panels, batteries, etc., etc. Everything is powered by microchips that, in a way, is a child of printmaking if we look at it that way. We gave the engineers the blueprint and they changed paper to silicon. The modern world isn't some mystical, obscure digital space. It's made of pressure, chemicals, and ink. The world is not built, it's literally printed. Thanks. I hope you enjoyed this video. If you liked it, subscribe to the channel and see you next time. Thanks. Bye bye.